For this example, we're going to find the equation of the line tangent to f of x equals the square root of 2x minus 1. Let's say at x equals 1. So right here is at 1/2. So we're going to look at x equals 1 and see if we can get the tangent line. So one thing I know for the tangent line that I need is the actual point. So I'm going to plug in 1 to get this, and I know that my point will be 1 comma, and then 2 times 1 is 2 minus 1 is 1. Square root of 1 is 1. So I know that 1, 1 will be on my tangent line. Okay, now looking at the picture, I know that my tangent line should be kind of shallow, so the number should be low, but it's also positive. So when we do this, we should get a positive number. Now I'm going to do the generic rule to find the equation of the slope of the tangent line. I'm not going to actually use the 1. So I have to pick two generic points, and the points I'm going to choose are going to start with x and x plus delta x. So I'm looking at an x value and then a little to the right of it. So if I look at x, the y value will very simply be f of x, which is the square root of 2x minus 1. If I plug in x plus delta x into my function, I get the square root of 2x plus delta x in parentheses minus 1. And these are two generic points. So I'm going to use the slope formula, and I have the square root of 2x plus delta x minus 1 minus the square root of 2x minus 1 all over x plus delta x minus x, which just simplifies to delta x. Now this represents the slope of the secant line between these 2 points, but if I take the limit as delta x approaches 0, that turns this into the slope of the tangent line. Now if you plug in 0 right now for delta x, you would get the square root of 2x minus 1 minus the square root of 2x minus 1, which is 0 over 0. So I know that I'm going to actually be removing a common factor when I do this. Since that's true, and I have square roots, I know the way to get to that common factor is to multiply by the conjugate. So I'm going to take the conjugate of the numerator, the piece with the square roots in it, and say that this is going to be multiplied by the square root of 2x plus delta x minus 1 inside the square root. I'm going to change the sign to a positive square root of 2x minus 1. And I'm going to multiply by the same thing in the denominators because it's a very, very clever form of 1. And that way I'm changing the way this function actually looks, but I'm not really changing the function itself. So when you do this, I'm still going to have the limit as delta x approaches 0, and I'm going to multiply the first term times the first term. So I'm squaring a square root, and this will be 2x plus delta x minus 1. A negative times a positive is negative. And then the square root of 2x minus 1 times the square root of 2x minus 1 is 2x minus 1. Make sure you have parentheses around this piece. You don't have to have them here because it's positive out front, but you do have to have it here, so you remember to distribute that negative. In the denominator, I'm not going to actually distribute the delta x because I know I'll be canceling it out. So I have delta x, then open parentheses, square root of 2x plus delta x minus 1 plus the square root of 2x minus 1. If you look in the numerator and you just simplify the numerator, this is a 2x plus 2 delta x minus 1. Distribute this negative, minus 2x plus 1. The 1's cancel out and the 2x's cancel out, leaving us with a 2x. So this whole thing becomes the limit as delta x approaches 0 of a 2 delta x over a delta x, and we can see that that's what's going to cancel out, times the square root of the 2x plus delta x minus 1 plus the square root of 2x minus 1. So our delta x's cancel out, and that leaves me with the limit as delta x approaches 0 of 2 over the square root of 2x plus delta x minus 1 plus the square root of 2x minus 1. Now I'm going to evaluate my limit. So this delta x is going to go to 0. And what I have here is just the square root of 2x minus 1 plus another square root of 2x minus 1. So I have that this equals 2 over the square root of 2x minus 1 plus the square root of 2x minus 1. If I keep simplifying, this is 2 over, you can see I have 2 of them. So 2 square root of 2x minus 1. I can cancel out the 2's, leaving a 1 in the numerator, and the slope of my tangent line is equal to 1 over the square root of 2x minus 1. So this is the generic rule for a slope of a tangent line. This would work at x equals 1, at x equals 4, at x equals 3, at x equals 0.75. So what I'm going to do for my tangent line is I know that I want the line tangent at x equals 1. So I'm going to plug 1 into this. So I'm going to get m sub t when x equals 1. So that will be 1 over the square root of 2 times 1 minus 1. Well, the square root of, 2 times 1 is 2, minus 1 is 1. The square root of 1 is 1. 1 over 1 is just 1. So the slope of my tangent line right here is 1. So my equation will be y equals 1. Then my point was 1, 1, so it's shifted 1 to the right and up 1. So this would be my y sub t. It's the equation for my line tangent to the function. If I wanted to use that line to estimate the function value, I could do it near x equals 1, but nowhere else. So I could maybe estimate f of 1.1 on this, f of 0.9. Now an interesting thing to note is what happens right here at 1/2. And I knew that 1/2 was the x-intercept because you can set square root of 2x minus 1 equal to 0, which means 2x minus 1 has to equal 0. Add the 1, divide by 2, x equals 1/2. So the question is, what's happening to the slope of my tangent line as the curve gets closer to x equals 1/2 from the right? And to me it looks like it's getting more and more vertical, like the lines are getting steeper and steeper. So I'm going to plug in 1/2 to this and see what happens. So m sub t when x equals 1/2 would equal 1 over, and then I know what happens with the 1/2 here. 2 times 1/2 is 1, minus 1 is 0. The square root of 0 is 0. Now I'm actually only coming to 1/2 from the right hand side. So I know that my x values are more than 1/2. So if I want to check the sign of this 0, I could plug in a number more than 1/2. So let's say I plug in 2. I could plug in 1. I'll plug in 1. 2 times 1 is 2, minus 1 is 1. The square root of 1 is positive. And my tangent line is approaching positive infinity. And you can see right here it's headed towards being vertical. So I would say that I actually, my slope is becoming undefined, headed towards being undefined as x gets closer to 1/2, and it would be undefined at x equals 1/2. So that's an interesting case for this problem specifically.